All right, so 2-3, this is going to be day one. We're going to split this one up into two different lessons. We're going to start with conditional statements. A conditional statement is a statement that can be written in if-then form. So your symbolic form is an arrow. So if you remember, conjunctions were like the up of a mountain, disjunctions were the down of a V. Now you've got, a single arrow. Make sure it's a single arrow. It is read if P, then Q. Or P implies Q. I've never seen it written that way except in this packet. The hypothesis is the phrase that immediately follows the word if, and the conclusion is the phrase that immediately follows the word then. No examples, sorry. So identify the hypothesis and conclusion of the following conditional statements. If you live in Nashville, then you live in Tennessee. Well, actually, you don't need the if in there. I don't know why I included that. So you live in Nashville follows the if, that's your hypothesis. You live in Tennessee is your conclusion. Some of these are that simple. Some of these take a little bit of finagling. So if the sum of the measures of two angles is 90, that's your hypothesis. Then they are complementary angles, that's your conclusion. You are literally breaking apart a sentence and rewriting it. If a quadrilateral is a square, that's your hypothesis. It has 4 right angles, that's your conclusion. So these kind of problems should be relatively easy for you. The writing them, these take a little bit more thought process. So you are writing the following statements in if-then form. So number 4, an obtuse angle has a measure greater than 90 degrees. If you notice, there's no if-then in that sentence, so you have to create the if-then. If an angle is obtuse, then it has a measure greater than 90. So if you notice, you're not writing it in the same format. You're taking what you're given and you're making it into a sentence that actually makes sense. I should probably scale out a little bit there, huh? There we go. Because you can't say, if an obtuse angle, then it has a measure greater than 90. That makes no sense. So you have to be willing to add some words and make your sentence make sense. So number 5, all numbers divisible by 4 are also divisible by 2. If a number is divisible by 4, then it is also divisible by 2. You don't technically need the word also, that you could just write, then it is divisible by 2. That's an option for you. Number 6, states on the East Coast border the Atlantic Ocean. If a state is on the East Coast, then it borders the Atlantic Ocean. Number 7, Valentine's Day is in February. I forgot a word. If it, there we go, is Valentine's Day, then it is February. And number 8, prime numbers only have 2 factors, one in itself. If a number is prime, then it only has 2 factors, one in itself. If you notice, if you're copying the notes straight off of the PDF that I attached to the day, the lady, the Gina Wilson that creates these, her answers slightly vary from mine, and that's fine. So your answers may slightly vary. And as long as you have, how do I put this? As long as you have the basics of it, the extra words don't matter quite as much. As long as your if-then is in the right place and, you've got to have prime numbers over here, you've got to have factors over here. The words in between aren't quite as important. So those were all conditionals. Your if-thens were conditionals. So your conditional is going to be if P, then Q. You have related conditionals. Related conditionals are inverse, converse, and contrapositive. Do you remember when I said when we started these lessons that you're going to be doing a lot of writing? You're going to be doing a lot of writing. Sorry about that. So your inverse is formed by negating the hypothesis and conclusion. So it becomes if not P, then not Q. If you remember, that little squiggle is the word not. Your converse is formed by switching the hypothesis and conclusion. So it becomes if Q, then P. And then your contrapositive is formed by negating and switching the hypothesis and conclusion. So it becomes if not Q, then not P. These things you're going to want to make note of because we're going to be doing them for 1, 2, and 3. It is just, you now have 4 different ways to write the same sentence. So write the inverse, converse, and contrapositive of the following conditional statements. Determine the truth value. If false, provide a counterexample. There are technical ways to determine true and false on these. This packet doesn't seem to follow those. We are just kind of using our common sense, which we have. So, we're going to exercise it. So, statement number 1. Oops. If it is Saturday, then there is no school. Hey, Jordy. Shh, please. So, it is Saturday, statement P. You may want to go ahead and highlight that. There is no school is going to be statement Q. We're going to do your inverse first. Inverse is if not P, then not Q. So if it is not Saturday, then there is school. To determine whether it's true or false, think about it. If it's not Saturday, then there's school. Well, you also have Sunday where there's no school. So that one's false based on, again, common sense. Your converse is if Q, then P. So we're taking this statement and flip-flopping it. So if there is no school, then it is Saturday. That's false because, again, no school. You don't have school on the weekend, Saturday and Sunday. Oh, I forgot. Coming back up here. Sorry, guys. See the no? When we went to negate, on our inverse, we negated the first and the second. Well, it is Saturday became it is not Saturday. There is no school became there is school. A negation either inserts the word not into a sentence or removes it. Sorry, I meant to go over that and I got sidetracked by my children playing with balloons. Sorry. So, contrapositive. So contrapositive, we are taking this statement right here and inserting nots. So this already has a word not. So if there is school, then it is not Saturday. Well, that's true. I mean, if you're going to school, and we don't have Saturday school anymore. So number 2, if the product of 2 numbers is odd, then both numbers must be odd. So the product of 2 numbers is odd. That's going to be statement P. Then both numbers are odd is going to be Q. This one, she definitely writes this one differently than I do. For your inverse, you're negating things, which means you're putting the word not in, right? So if the product of 2 numbers is not odd, then both numbers must not be odd, which is a mouthful at best. But what she writes is she puts even in there because if you think about it, the only numbers that are not odd are, in fact, even. But when we're writing these sentences out, the word not is rather important to the fact of what you're doing with the inverse, converse, and contrapositives. So I would rather you write not odd instead of writing even. But, if you need to write out that it's even to kind of make this make sense. So if the product of 2 numbers is even, then both numbers must not be even. So that's false because you can do 4 times 7, which is 28. I mean, oh wait. There we go. Got it. Then both numbers must be even. So can you, in fact, get an even number if you are multiplying numbers that are not both even? So your converse, if both, no, back up here. We're taking this statement and we're switching them, flip-flop. So if both numbers are odd, then the product of those numbers is odd. So trial and error, 1 times 9 is 9, 3 times 7 is 21, 15 times 3 is 45, 5 times 7 is 35. That one is true. That's just trial and error. Keep trying until you figure out that nothing's working to prove it false. Your contrapositive takes this statement and it inserts not. So if both numbers are not odd, so even, then the product is not odd, so even. So if both numbers are even, then the product is even. 2 times 2 is 2, 4 times 8 is 32, so on and so forth. That one comes out true as well. Number 3, if the temperature is 25 degrees Fahrenheit, then it is below freezing. The temperature is 25 is statement P. It is below freezing is statement Q. If the temp is not 25 degrees, then it is not below freezing. Well, that statement is false just for the sheer fact that you still have temperatures that are below freezing that are not 25 degrees exactly. You can go further down. I think the notes that she had, I think she puts like 24 degrees Fahrenheit instead of 25, whereas I put 0. Your converse, do a flip-flop. If it is below freezing, then the temp is 25 degrees. False. Just because it's below freezing does not mean it's exactly 25 degrees. It can be any other degree. And your contrapositive, which negates this one. If it is not below freezing, then the temperature is not 25 degrees Fahrenheit. So if it's not below freezing, that means, obviously it can't be below 32 degrees Fahrenheit. So it's not 25, so that's true. So writing the sentences shouldn't take anything. It is just following this protocol. That is all you're doing. The determining the truth value, that's where the thinking comes in. Let me know if you need any help.